Hey, welcome to lesson 10.3. We're going to be learning about chords. Now, what is a chord? You might be thinking it has something to do with music. It doesn't, but it kind of does. But it doesn't. We're going to be talking about chords. And what is a chord? Now, if you look at my little drawing down here, all right, you're going to see a chord. Now, there's two things here. There's a radius and a chord. We know CE is the radius because it starts at the center and it goes out, right? So that's a radius. And the chord is AB. What makes AB a chord? Well, it's a line in a circle that has endpoints on the endpoints on the circumference. Endpoints on circumference. And that's what makes it a chord. Now we're going to be learning an interesting theorem today. All right, two of them actually. And the first one is called the intersecting chord and radius theorem. All right. What is this theorem? I will tell you. Let me just clear a little space right here. All right. The intersecting chord radius theorem is this. In a circle, a radius that is perpendicular to a chord, and remember perpendicular means makes a 90-degree angle. So a radius that's perpendicular to a chord, just like in this case, right? This radius is perpendicular to this chord, bisects the chord. So the radius, because it's perpendicular to this chord, has bisected the chord, like so. So what do we know? If CE is perpendicular to AB, then we know AD must be congruent to DB. All right, that is our first theorem. So let's use that first theorem to solve a problem. In circle A, radius AD is 10. All right, we got this radius, this is 10. Okay. Chord BC is 16 centimeters, all right, and this is perpendicular. This is perpendicular to the radius AD at point F. So we know that this radius is perpendicular to this chord like this. What is the length of BF and AF? Okay, let's solve this problem. Well, the first thing we want to know is BF, which is right over here. Okay, well, what do we know? Since the radius is perpendicular to the chord, we know it cuts the whole chord in half. So if I know that the whole thing is 16, well, what does that mean? That means that each of these are congruent and that it's 8 each, right? So all I had to do was take my 16 and divide that by 2, which gave me 8, right? The radius cut it in half because it bisects it. 2, we want to find out what AF is. And that's where it gets interesting, right? Because all I know is that this radius is 10 and the chord is 16 and that these parts are 8. But now I want to find out AF, which is right over here. How the hell am I supposed to do that? Well, luckily I'm here to help you. Now you might be thinking that the chord bisects the radius, so this would be 5 and this would be 5. But that's incorrect. That is not part of our theorem, okay? That is not part of our theorem. This is what you can do. You could follow these 3 easy steps and that will get you to the answer. The first one is to find the length of the radius. The radius is 10 centimeters, okay? 2, I'm going to draw a right triangle. And what do I mean by that? What I'm going to do is draw this right triangle like this. I'm going to start at the center again. I'm going to draw a line out like so, all right? Now, what is the length of this line? Because this is also a radius, this line that I just drew to make my right triangle. It's also 10 centimeters. Oh. Now maybe you see where I'm going with this, okay? So I have this length that's 8, this length that's 10, and I know this is a right triangle. So can I find my missing side over here, which we'll call x? I sure can. All I have to do is use the Pythagorean theorem, which is a squared plus b squared equals c squared. Okay? So what's my radius? Well, it's always across from my 90-degree angle, so my radius would be 10. And now I just have to plug in. 8 squared plus b squared equals 10 squared. 64 plus b squared equals 100. B squared, I'm going to subtract 64 from both sides, gives me 36. So my b is equal to, when I take the square root, 6. X is equal to 6. Good, so I solved my problem. So now I know that BF, we found out, was 8, and we found out that AC in this case, or sorry, AF, my B, is 6. Oh, now you might be saying, that's pretty crazy, Mr. Siegel. I don't think I can do that. Good thing we're going to try it 2 more times, kids. All right, in the diagram below, the diameter, all right, AB, bisects chord CD. So this whole diameter bisects chord CD. So actually cut it in half. At point E, sorry, in circle F. If DC is equal to 10, all right, this whole thing equals 10, and AF is equal to 13, AF is equal to 13, what is the length of FE? Okay, so let's finish this out. Okay, so we know the radius is 5, we know that our chord was bisected, and that the chord was 10. So if it's bisected, right, if the whole thing is 10, and it's bisected, that means I cut it into 2, and it gives me 5. So each of these is 5. Now the question is, what is the length of FE, which is right over here? Oh, this is very similar to the last problem, right? Well, how am I going to do this? Well, what I'm going to do, once again, is find the length of the radius to start off with. And the radius is 13 in this case. The next step is to draw a right triangle. And I'm going to do it the same way I did in the last example. Okay? We're going to start here, and we're going to make a right triangle right here. Now, how do I know that this is a right triangle? Well, if these are bisected, then I also know that this must be perpendicular. It's part of the theorem. All right, the length of this line that we just drew is a radius again, right? This is a radius, just like this is a radius. And since these are both radiuses, we know that they're same length. So this is 13 as well. Since I'm looking for FE, I'm going to put an X there. And once again, I can use the Pythagorean theorem, which is just A squared plus B squared is equal to C squared. All right, let's plug what we know in. We know A is 5, okay? We don't know what B is because that's our other leg. And we know C, which is across from my 90 degrees, is 13 squared. We're going to solve this equation now. 25 plus B squared is equal to 169. I'm going to subtract 25 from both sides. Follow me up here, and I get B squared is equal to 144. Solve it out. Let's take the square root, and we get B is equal to 12. Okay, so we know our missing side length is 12, so FE has to be 12. This is a 5, 12, 13 triangle. Let's try it one more time. I know you're still confused, so let's try it again. Let's see if we're getting the hang of it. In the diagram below, diameter MN bisects chord PO. So PO got bisected at point R in my circle S. Okay? If I know that RN is equal to 2, and MN, this is the whole thing, is equal to 34, then what is the length of PO? Well, follow me while I help you with this question because this is pretty hard. Okay? Step 1. I'm going to find the length of the radius. That's still what I want to do. Well, if I know this whole thing MN is equal to 34, what's my radius? Well, the radius is just half the diameter, right? So my radius is just going to be 17. All right, so my radius is now 17. Next thing, I'm going to draw my right triangle. So let's do this again. I'm going to draw my right triangle. And once again, since I know that this is also a radius, right, from the center to the outside, this is also 17. Well, now I'm going to use the Pythagorean theorem to solve this, but there's a problem here. I don't have a second side. I just know this outside over here. How am I going to figure out what one of these two sides is? They didn't give me the length of PO, or PR, or RO, and they didn't give me SR, which would be helpful, right, when solving this. What's a boy to do? Well, let me help you out. Since I know that SN is also radius, I know this whole thing must be 17, right? If this part is 2, what must be this missing part? Well, I could just do 17 minus 2, and the missing part is just 15. Oh, you see what I just did there? Excellent work. And now we have two sides of our right triangle. Hope that made sense to you. Watch it 7 times if you need to. This is 2, the radius is 17. I just subtracted them to get my missing part, SR. Well, now let's just do our solving. A squared plus B squared equals C squared. A is 15 squared. C is going to be 17 squared. Let's do some solving. 225 plus b squared is equal to 289. I'm going to subtract 225 from both sides. Bring this stuff down. I get b squared is equal to 64. Take the square root of both sides and I get b is equal to 8. And how about that? I know that my missing side is 8. Oh, but I just made the mistake I, the math teacher. This is not 8. Oh my God, I'm so stupid. That is what PR is equal to. No, I shouldn't make that mistake. I'm trying to find out what PO is equal to. Well, since I know this chord was bisected, if this is 8, I know RO is also 8. So if I want to find out what PO is, it's the whole thing, so it's just 8 plus 8, which is equal to 16. Oh, that was some work. We're getting smart up in here. Okay, the second theorem we're going to be using, and this might be a little simpler to you, so I probably should have started with this, but nah, why would I do that? The parallel chords theorem, okay? The parallel chords theorem. What is it? Why do I have it? I'll tell you right now. The parallel chords theorem is this. If two chords are parallel, such as AC, which is a chord, remember it's a chord because the endpoints are on the circumference, and BD are parallel. If these two are parallel, well, what do I know? Well, then I know that parallel chords intercept congruent arcs, okay? Then my two arcs that they intercepted are congruent. So that would tell me that AB is congruent to CD. So if AC is parallel to BD, we know AB is congruent to CD. That's the whole theorem. Parallel chords make congruent arcs. Easy, right? So if this was 100 degrees, then we also know AB is 100 degrees. All right, let's try this out. In circle K, GD is parallel to FE, so my two chords are parallel, right? If the measure of GF, arc GF, is 56 degrees, what is the measure of arc DE? Well, I think we figured this out. If GD and FE are parallel, we know that these two arcs are congruent, so this is also 56 degrees. So we would just say that the measure of DE is equal to 56 degrees. And you'll see here I also put this little congruent mark here. Just for your information, we'll just put GF is congruent to DE. Right? Nice to know. All right, let's get a little harder up in here. 2. In circle E, OP is the diameter of the circle, and MN is parallel to OP. So we got our two lines right here. They're both chords, and we know that OP is the diameter. If the measure of MO is 40 degrees, what is the measure of MN? So it's not asking for NP this time. We want to find out what NM is. All right. Well, we know that MO and NP are congruent. Why do we know that? Because these two chords are parallel, so NP is also 40. MO is congruent to NP. Okay? But we want to find out what MN is. How are we going to do that? Well, as I said, diameters are a very interesting word. This word is big. They put it in there for a reason. And that's because it tells us that this is half the circle, right? So we know this whole arc will be 180 degrees. Remember, a diameter intercepts 180 degrees. So to find out what MN is, all I have to do is 180 and subtract these two other little arcs. Minus 40, minus 40, and that gives me 100 degrees. So arc MN is 100 degrees up in here. And that makes sense, right? 40 plus 100 plus 40 is 180, and that's half my circle. Sweetness. All right, last problem. In circle M, EV is parallel to LO. All right, so that's probably telling us that these two are parallel. VO and EL are congruent to each other. Okay? If the measure of LO is 150 degrees, all right, and EV, which is over here, is 110 degrees, what is the length, the measure of EL? So look at this. We know these two outside arcs. The two outside ones are 150 and 110. but what we're looking for is EL. Well, how are we going to solve that? Well, if you notice, all of these arcs should add up to 360 because this is a circle, right? So if I want to find these missing 2 arcs, all I have to do is say 360 minus 150, which is this arc, minus 110, which is the top arc, equals 100 degrees. All right? So that tells me that both of these are 100. So don't just write here. I've seen this a lot. Don't write 100 and 100 and you think you've solved the problem. Because if you add this up, 100 plus 110 plus 100 plus 150, that's actually 460 degrees, and you went over. What you forgot to do is the crucial final step is this. These two congruent pieces add up to 100 because they're both missing. What I need to do is divide this 100 into 2, and that gives me 50 degrees. So this would be 50, and this would be 50. So my final answer would be EL is equal to 50 degrees. And check this out, if you add these 4 numbers together, 50 plus 50 plus 110 plus 150, what do you get? 360. These two are congruent, and that's how you know you did it right. All right, guys. Hope that didn't confuse you too much, but if it did, figure it out.